Have a talk by Paige, who is somewhere too, from Zcash. Yeah, over there. I'm sure everybody's heard of Zcash, or most people have heard of Zcash. And also, thanks so much to Ryan for, as always, doing his amazing work with live streaming and recording it, and also helping set up the meetup with Paige. And then finally, we have all the way from Korea, the guy from BOScoin. So thanks so much, Ash, and thanks so much you guys for coming over. Also, they have sponsored the location here, so thanks so much for that. There are drinks in the back. There is also a QR code there for like Bitcoin and Ether, so you can pay like euro something or two. If you can't afford a Bitcoin transaction, you can leave it in coins as well, which might be more economical. And yeah, with that, all over to you.
Thank you for the nice introduction. Welcome to our presentation. I'm here to talk about Bitwala and what we do since 2 or 2.5 years with our company. International money transfer sucks. If you think about it, like with communication, everything is fine. You can transfer, you can send money, you can send messages around the globe within a few seconds. So when I deal with my business partners or my friends, everything in communication is fine. If I do the same with my online banking, it's ridiculous. It costs a fortune to transfer the money there, and it takes up to 5 days until the money is there. And now think about it again. We live in a time where everything is modern. We have AI, we have blockchain technology, we have so many new things all over the world. And my online banking still needs longer time than an actual physical transportation with a plane, car, or with a train is slower than my online banking. I think this is fact, and we can all agree that this is not the future of payments. Well, luckily for us, there are many solutions. It's not only Bitcoin, but all the cryptocurrencies solve this problem. They're almost instantaneously, they're all over the world accessible, and they have quite low fees, so they're quite reasonable. So the question is, why is not everybody excited about it? I mean, in this room, everybody is excited about it. But if I'm at mainstream events, most of the people look at me and like, yeah, but this is something weird. And I think, yeah, it has 3 reasons. First of all, the volatility. I mean, we saw it the last few days. Ethereum went up, Bitcoin went up, goes up, everything goes up, so we are all fine. But if you run your business entirely on Bitcoin or on other cryptocurrencies, and these currencies go down, then you really put your business in risk. And for me as a business owner, that's something that I can't take or only take until a certain point. So I have always some liquidity in euro to pay my bills. And this is something that is still there. For mainstream users, I mean, for you all, it's quite intuitive. So you signed up on different platforms. You all have an account at Kraken or Bitstamp or the other ones. But for a mainstream user, it's a mess. So you have to do KYC, you have to upload your documents, you have to verify everywhere, and it's just complicated. So after the second exchange, they're like, okay, I'm out of it. That's too much. And the worst problem is it's not everywhere accepted. So what can I do with my money if the third party or the counterparty doesn't accept my money? So it's worthless. And this is how we started Bitwala. We said, okay, let's make it happen that we can spend our coins like everywhere where we want to. We solve step by step everything that we thought is necessarily to do so. So we have now more than 20 currencies that we pay out. We have 200 countries where we are active in. We have like an intuitive app where you can just sign up, verify, and start transferring money. And we have our Visa card where you can pay where Bitcoin is not accepted. The more we developed it, the more we saw like how fast and how easy it is to transfer money with us. So when you're now a customer of Bitwala and you have your money, like your Bitcoins or Zcash or whatever is accepted by Shapeshift, you can transfer this money like directly from your mobile phone to these countries. And here, I'm not talking about Bitcoin or cryptocurrencies. That's actually the money on the bank account of the recipient. And there you see we have countries like China, Japan, Philippines, where it's almost instantaneously there. And we guarantee that the money is on the bank account in less than 24 hours. And this is something that the SWIFT system could never achieve. Even though like we're cheaper than the SWIFT system, we're 3 to 5 days faster than the traditional online banking. With our with our Visa card, you can spend money everywhere. You can get money from the ATM, and like as you see in our Trustpilot profile, like everybody loves us. Like everybody who's using us gives us like a really good rating because we're by far the cheapest credit card on the market when it comes to cryptocurrencies. We're quite fast. So after 10 minutes, everything is on your card. The top-ups move almost instantaneously. So they wait until one confirmation and then it's on your card. And you can order it in over 100 countries. But the more we did that and the more we developed Bitwala, the more we realized that we really need to dig deeper and to go one step further to make this accessible for the mainstream. And we're now really proud to announce that we're one of the very first companies in the world who can serve our customers soon a full working crypto bank account. That means you get on the one side full protection by the government and by insurances. So you get until 100,000 euro, everything guaranteed on your bank account. You get your SWIFT or IBAN account. You get your BIC, everything that you know from your normal bank account. But on the other side, you have the Bitcoin wallet right attached to it. So you can swap between Bitcoin, other cryptocurrencies instantly and totally legal in your bank account. We came quite far, as we heard before. We started quite early. So Bitwala is now almost 2 years old. We got a funding 1 year ago, and now we have more than 20,000 users. We transferred more than 10 million the last 12 months, and we still keep our month-to-month growth rate of 30%, which is for a small startup still quite an achievement. Who we are is like myself, Jörg, and Jan. We're in the Bitcoin community since 2011, 2012. So we really know what the Bitcoin users want, or the crypto users want. And this is also the beauty out of it. So we came out of the crypto economy, and we decided to change something and to offer a product that is needed by many of us. Yeah, we're now closing a round of 2.5 million. We're really proud that hopefully today was the last meeting. So we got a handshake deal of 2.5 million for our next round. So we're really happy on this achievement. And if you want to be a part of it, then please download our app, be a part of our community, help us, and transfer money in the modern way. Thank you.
Okay, hi. I'm curious. So, what's the magic behind getting a transaction done within 1 day?
Good partners and good banking relationships, and also that we really send the money to the recipient country, and there change it to fiat currency. So we actually get rid of the SWIFT system entirely. We never use it. We never touch it. We only do local transfers in the local market.
So essentially, you have someone, locally in the country who essentially gives some money, to them in real time.
Either or. There are two options. Some countries we have partners, and some countries we have our own banks, right? So we have corporations with we have corporations with banks, and then we transfer the money and exchange it ourselves. But on the other side, we also work with partners. So we're launching in the US soon, and there, as you all know, it's a pain in the ass. So we have a partner there who has the license for the 50 countries in the United States, and therefore transfers the money for us in the receiving country. It depends on your verification level. So like it starts from 200 euro that you have to verify yourself, but as soon as you're a business customer fully verified, then you don't have any limits.
But is it legal? What about tax issues?
Yeah.
Whenever I travel, by plane, they ask me, do you bring more than 10,000 bucks into my country?
Yeah, so I'm not a tax consultant, and this is always what I say. Like, we can't change the people, and if the police comes to us, or like if there's an investigation, we have to cooperate. So we always recommend not to launder money, not to do this, because you're fully verified, right? So as soon as, and this goes so far, when you want to have unlimited, so over 2,000 euro lifetime value, then you really have to call us on a Skype call. So there's not even like a chance that you could use fake IDs or whatever, so we really make sure that this is the person, and still we have more than 10,000 verified customers. So I think like in the beginning everybody said like, you're crazy, why are you doing this? Everybody in Bitcoin is so obsessed with this privacy, but we said if we want to make this work and if we want to get it like accepted by our government and by the German BaFin, we have to introduce these rules, and most of our customer understood it. And yeah, so that's the...
Now, if I want to send money to Colombia, for example, I need to transfer the money from a bank account to some money transfer company. It takes 1 to 2 days.
Yeah.
Then they send it to a Colombian bank.
Exactly.
And the Colombian bank puts it on the account of the person.
Exactly.
And they take, so the money sender takes 2%, 3% to convert that money into the euro, into US dollar, because the Colombian bank only accepts US dollar.
Exactly.
And the Colombian bank takes a few percentage again to receive it.
Yeah.
So what would I need to pay in your case?
0.5%. That's easy to say because we have a similar case in Mexico and many Middle American countries and South American countries. They have the exact same thing. So it always goes over to the United States and gets processed there in US dollar and then in Mexican pesos to Mexico. So the whole process takes like 5 days. With us, the money is there almost instantly because we don't take the bridge over the United States. We go directly Bitcoin to Mexico, change it in the Mexican market and send it out locally. So we don't have this. And like in our case, Mexican pesos, check it, 0.5%, and it's there within 6 hours, guaranteed.
And the Mexican bank takes some money to put it on the bank?
No, because the local, like surprisingly, the local banking system in Mexico is quite nice. So it works quite fast. The fees are low, but the Americans take a lot of money out of it when you transfer money to Mexico. So it's really fascinating that Mexico is one of our fastest countries because they have a really good banking system. It's weird, but it is true. Yeah.
So I love the progress you guys have made, so congrats on that.
Thank you.
Bitcoin obviously has its woes. What if there's like a major fork, like China partitions itself or something? Do you guys have backup plans?
Yeah, we already accept all cryptocurrencies. So it's not Bitcoin only anymore. We're also thinking about integrating other wallets because we're aware of the scalability problem, many other issues in Bitcoin. Also, we believe in evolution in things. So we also integrate other cryptocurrencies. And as soon as the order books are deep enough for us to make higher volume transfers, like Kraken Ethereum at the moment works already. So we're now looking more and more deeper inside of it, and all the programming that we did was from the very beginning modular. So we always said like we don't build something based on Bitcoin, we build something based on blockchain, and this is why it's called blockchain banking. They always ask me like, you do only Bitcoin? We're like, no, we don't. Yeah, for normally with my investor slides, I always show the prices and times of TransferWise. So most of the countries where, like, let's take China, for example, TransferWise asks for 1.9%, we ask for 0.5%. TransferWise to China needs 5 business days, we need 1 business day. And this is something where they can't get around the new technology anymore because they see that we're literally changing how they should do their business. The minimum transfer amount is, I think, €5. And at the moment, we have a minimum fee of €1, but we get rid of it soon. Yes? Yeah. And in Korea, we have... Yeah. Yeah, Korea is a good example because I know the guys quite well. So they're from Hyphen and Corbett, and we work really close with them. So they handle all the legal requirements in the receiving country. And you can try it now if you sign up and you transfer money to Korea. When you're home, it's definitely there. Yeah, they like in this specific case, they have their own, like Hyphen has its own exchange and sends it out, and they're also working with a big Korean bank together, also with a Japanese bank. So they handle this in this receiving country for us. Yes.
From the side of the shop owner, can I use your system so to get my customers pay me via your system?
Sure. Yeah.
In Berlin, my client is in Mexico.
Yeah, give me an email. I shoot you a referral code, then you can sign them up, of course. Yes.
What you talked about was about making the traditional world work, or interfacing with the traditional world. How much blockchain is there still in Bitwala, and is there anything that you're doing with blockchain that you couldn't do without blockchain?
Everything, like with Bitwala, everything is blockchain, everything is Bitcoin. So when you want to use it at the moment, you need Bitcoin, you need Ethereum, you need Zcash, you need whatever you want to even use it, to even get started, right? In the future, even like we see us as a gateway to these new technologies. So this, what we show there, that we exchange in the receiving country, this is like an intermediate step. But what we think is important is to onboard the people here quite easy and to tell them, you know, you don't have to be afraid of volatility. You don't have to be afraid of any risk. But if you want to use this technology, just swap it and send it over. And if the receiver accepts Bitcoin, Ethereum, or whatever, that should be our mission. Like we really see it as a browser for people who don't understand it from the very beginning.
I have a question, how you see yourself comparing Ripple after 5 years? Because they seem that they're going to rehash on international.
Yeah, Ripple I know quite well because now we're working close. They get an access point and a Bitwala bank account. So they're actually our customer, not our competitor. Yes.
So in Germany, it's quite, compared to other countries, it's quite costly to withdraw cash, for example.
Yeah.
Number 26 had it last year, it was free. Now they added like free or something.
Yeah.
But can I use your card and then pay 0.5% to withdraw in all ATMs in Berlin, for example?
So there is an ATM fee that you always have to pay. This is €1.50 or something. We can ask Jan for the specific numbers, but it's a really low price for the value that you get. And the thing is, every little bank, every big bank has to pay this because this is the fee that Visa and the ATMs take. What numbers 26 does and what other companies do, they just pay this and cover this for the customer because they say, yeah, okay, it's going to be fine. But in the end, you saw that with number 26, the people used it too much. And then they said, okay, we put a gap on it, except for when you have more than €2,000 on your bank account, which is like a two-class bank account. And we didn't want to introduce that. So we were transparent from the very beginning. There are many issuers of debit cards who go another way. They say everything is free, everything is easy, and then they don't charge anything. But if you take a closer look, it's really intransparent. They ask for different fees. And in our case, you can 100% trust. You always get spot rate. You always get your 0.5%. And we're not going to hire this at any time. We're talking about lowering it because now it's really growing and we have some income. But in our case, it's different. We always charged money and didn't say it's for free.
One more. Then it's a very fast way to withdraw, let's say, euro, because if I use Kraken, it takes 2 or 3 days doing a SEPA transfer.
Yeah.
But with you, I can do a Bitcoin transfer to your address.
Yes.
And withdraw it with the Visa card.
Exactly. And that's a use case. This is why 60% of our customers come outside of Europe, because they say that's the easiest and most convenient way to transfer money to Europe, actually, because it's so fast, so lightning fast. Euro, like we had one guy from New York, he signed up, like before we closed them down. He signed up, he sent money from New York. 37 minutes later, he called on our support line and was like, how did you do that? And we're like, yeah, welcome to Bitwala. He wanted to stay a customer, but now.
Have you ever been hacked?
No. We got DDoSed. I always tell this story. It's really funny. We got DDoSed once, and we were sitting. We didn't have an own office. We were just us three, Jan, me, and Ben, sitting there. And the website went down. And then we got like a letter. Please pay this and this amount of Bitcoin. And then we were panicking. It was like, what can we do? What can we do? What can we do? I'm like, okay, I write this guy. And they're like, are you fucking crazy? What do you do? And I'm like, you have the wrong people here. We're sitting, three of us in a room, panicking, and we don't have money. So go for 2 minutes later, DDoS stopped. So you can talk yourself out of it sometimes. Not always, but if you're such a small team without funding, it works. So KYC is pretty straightforward. We say until 200 euro because we can monitor where the money goes to. So there's no way that you can open up multiple bank accounts and bank accounts with Bitwala and collect it on one bank account. So we always make sure that there's not more than 200 euro on each bank account. And as soon as there's more, then the verification process starts. So the first step until 2,000 euro is the documents, ID, and like a utility bill. And from 2,000 euro, then we ask to call you. Like you can even stop by in our office if you don't trust our network, and then we do the KYC offline. That works too. Yeah, I guess that's it. Otherwise, it went too long.
Hi, everyone. Starting a timer here so I don't talk too long. My name is Paige. And I'm from Zcash. Cool, thanks. My name's Paige. I work for Zcash, and we're all about privacy on the blockchain. I assume most people here know about Zcash. Raise of hands if you don't know Zcash. Oh, okay. Well, let's pause it then. Oh, wait.
I think it's okay now.
All right. Well, okay. All right. Start over. So most of you know Zcash. So we launched our blockchain on October 28th of last year. And if you aren't aware, Bitcoin is extremely transparent, not according to a lot of the media reports, especially in the early days, reporting that Bitcoin was this anonymous cryptocurrency and whatnot. But Zcash is essentially an attempt to solve the problems of privacy when using cryptocurrency. So we're all about fungibility and financial confidentiality. Fungibility is essentially being able to send a value without it being interpreted differently in any way. So if I send you 1 Bitcoin from an account that might be considered illicit in some situations, then it could be valued differently depending where you're sending it to or who's valuing that money. So if you have privacy properties, you can essentially guarantee that all money in the ecosystem is equal. And financial confidentiality is essentially just being able to send money privately, right? You don't want to have all of your transactions recorded on this global public ledger for everyone to see. And how we do this is using a pretty advanced cryptographic standard called zero-knowledge proofs. Are the scientists that developed the technology work kind of in the background at Zcash more as scientists and advisors, but they're still kind of helping us and improving the protocol as we move along. One thing that's really interesting about zero-knowledge proofs is the requirement for this shared public key. But in order to generate this shared public key, you need to also have this shared private key, which is a problem if someone has that full private key, then they can essentially do a lot of bad things, not necessarily compromise the privacy in the network, but they could essentially create as many Zcash tokens as they want. So we did this really cool multi-party computation ceremony right before the launch, and it's actually a really neat thing. We documented the whole thing, but what it came out of it was this public key that was split into shards, along with the private key split into shards, and each individual party was able to was essentially destroyed their private key shard, and as long as one person in that group just successfully destroyed their private key shard, then this is a safe network to use. Our scientists that have developed this protocol of zero-knowledge proofs are working on new ways of doing a ceremony that wouldn't require this private key that could be compromised. So that could be coming in the future, but right now it's really not at an efficiency level that we're comfortable with. But the actual ceremony is a really cool thing, and you should definitely look into it. There's a lot of documentation about how we did that, and it was a really long, complex process. So we are a fork of Bitcoin at 0.11.2. We're kind of integrating some of the upgrades that Bitcoin's done in the recent years, and kind of picking and choosing the ones that we like, but a lot of the stuff we are working to integrate as well. So because we forked from Bitcoin, we were able to essentially keep this transparent side of Bitcoin while also maintaining the zero knowledge shielded side. So what comes out of that is our transparent addresses, which are public and verifiable, essentially Bitcoin addresses, and then shielded addresses, which use this zero knowledge proof technology, and everything involved in the transaction, meaning sender, receiver, value, and we also added a memo field, is encrypted securely before it's stored on the blockchain. The receiver and sender have access to that data, but no one else does. So what is also interesting about this concept is that you can send money in between, send ZEC in between these shielded and transparent addresses. Transparent addresses have been really helpful in these first few months because they're essentially Bitcoin, and it's really easy for third-party wallets to integrate them. So most of the third-party wallets you see now using Zcash are first integrating the transparent side of things and then working to improve and integrate the shielded side. So yeah, this slide is just kind of going over the very basic idea, the very basic ways you could send money. So if you're sending from a transparent address to another transparent address, you can essentially see that as like a Bitcoin transaction. Sending from transparent address to a shielded address, your output of the transparent address is public, but the shielded part, it basically becomes consumed by the shielded layer in Zcash. And that can go the other way around. You can output into a transparent address and basically revealing the value from the shielded pool. And then obviously payments sent between shielded addresses are completely encrypted, and you don't know any data, any of the value sender receiver, or if there's a memo field included, that is not revealed as well. So it's interesting, especially comparing Zcash to other kind of privacy-preserving cryptocurrencies. We have a relatively high privacy set. Some scientists refer to this concept as an anonymity set. But what it comes down to is that the more objects you have in this pool, and the greater this pool is, the more, the less it's hard to pinpoint one individual object in that pool. So the more shielded addresses that are in use in Zcash, the more private it is for everyone in the ecosystem. And if you compare that to other cryptocurrencies which use like ring signatures or kind of mixing systems, you really only get this this anonymity privacy set of what is included in that mixing, that temporary mixing situation. So if you're combining a handful of transactions, there's only maybe 5 or 10 addresses which make up that privacy set. So the privacy set in Zcash is essentially the number of shielded addresses that are in the ecosystem. So we definitely want more people to be using these shielded addresses because obviously it just increases the privacy for everyone in the ecosystem. We do right now have not really like, it's a downside in that it requires more memory when you're creating the transaction than a lot of, for example, mobile devices can handle right now. So most shielded payments happen on computers, laptops. It's around 3 gigs of memory for like around 40 seconds of time. So that's something that that we're continuously working on internally, but we're also trying to solve that externally with other things that I will talk about at the end, or perhaps at the next slide. One thing I should mention is that even between two shielded addresses, the transaction fee is always transparent. So it's really important for users in the ecosystem to be using basically a standard transaction fee because you can essentially correlate. If you're using a unique transaction fee, someone might be able to eventually correlate those payments with your identity or make an identity profile around those unique fees. But yeah. So some of the things that we're working on include making the ecosystem more shielded and improving the infrastructure overall. The two things I'll talk about more in depth are payment disclosure and payment offloading right after the slide, atomic cross-chain transactions between, I should have written out the whole term, between different blockchains. So it's essentially a decentralized exchange, but the different blockchains need to kind of upgrade and integrate this process into their technologies as well. So it's kind of like we have to be working together to make this happen. And then so right now we're on the Sprout series, the first series of releases that we're doing. The next release will be Sapling, which basically does a crypto upgrade, which isn't super, like, it doesn't add a bunch of frills, but it really makes things a little, it makes the security better, while also making the verification of the zero knowledge proofs slightly more efficient. So we're basically working on the infrastructure in that concept. And then additionally, that will allow for user issued assets, which we're also heavily exploring So to talk more about payment disclosure, so right now, if I give someone cash, which is essentially what Zcash is trying to be, something that's a private transaction, you can't really prove that I gave you cash without some sort of receipt that happened that we both sign. So the same thing happens with Zcash. If I send you a private payment, you can't really prove that. You can't really prove that I sent you the payment, or I can't prove that I sent you the payment, or there's basically nothing that is revealed that would be able to prove this. So you kind of need a receipt. So we're working on this this payment disclosure concept that would output a key that would unlock the private transaction on the blockchain, depending on who you gave it to. So if you give it to a third party, then they would be able to read the contents of that transaction. So yeah, it works for if you need to prove the payment to a sender, or if you need to prove it to a third party. And obviously transactions between transparent addresses are verified on the blockchain because they're public. But anything involving a shielded address requires this payment disclosure, which will really benefit the ecosystem and really help to get more people to be using the shielded address side of things, which is what we're trying to push for. Right now we have, I think it's around 30% of the transactions in Zcash involve a shielded address. It's hard to decipher how many of those are shielded to shielded because of the privacy and anonymity inside of Zcash. But it's a subset of that, and we really want to increase that. So the first implementation of that will be an experimental thing that we're going to release in the next, hopefully in the next release, which should be in a few weeks. But as development happens, things get pushed back sometimes. So crossing fingers that an experimental version will be out. It's experimental because it does include a privacy leak for example, if you're sending a payment to a shielded address and you have a change address in there as well, then you could potentially reveal the transaction details of that change address. So it's a minor privacy leak, but it's something that we don't want to be the main property of this. So we're going to be releasing it as an experimental feature, and people can play around with it, and we'll work on improving that privacy leak. We have a few methods that we're exploring to do that. Yeah, and then something else that will also really help increase the use of shielded addresses is this concept of payment offloading. So I mentioned before that paying to or paying from a shielded address requires around 3 gigs of RAM. This concept will basically make a server-side implementation, so you can push that proving to either a third party or maybe a personal server that you keep at your home. So you can pay from shielded addresses on a mobile phone while having this offloading service do the actual computation. It wouldn't, it has vulnerabilities in that they would be able to keep track of that shielded aspect, but it wouldn't be able to make payments for you. You would still need to sign the transaction after the zero knowledge proof was generated. So yeah, so that is one thing that's really, I think, going to be a big step in terms of making shielded addresses more usable, especially for a lot of the mobile wallets out there. And it's something that we're really interested in talking to developers that are potentially interested in building these types of services with us. Essentially, Zcash is this brand new ecosystem, and there's a lot of potential for it. And especially compared to cryptocurrencies that exist already. And we have a ton of new features that are coming down the line in the infrastructure, and we like there's just a lot of opportunity for developers to take these on. So if anyone is interested in building these things, it's highly recommended to like get in touch and look into things and do more research. We're very open about our development and everything. So definitely talk to me here or get in touch online. Yeah, and this one is also, this payment offloading is also experimental release that we're hoping to have in the near future, maybe the next, the upcoming release, same as payment disclosure, but it would be very basic proof of concept proving service that someone could play around with loading up on like a home server or something like that. And I think that's it for my slides, but I forgot to add a slide of stuff that I want to talk about. So I wanted to talk about just like the going off of the lot of opportunities for developers. We do already have a really diverse community. So Zcash as a company, Zerocoin Electric Coin Company, I should say, we have essentially this Linux supported, officially supported client that's not a UI, it's command line only, and you know, that's obviously not going to work for a lot of people. We do have a community that have developed Mac and Windows clients as well, so definitely look into those. And there's also this really neat block explorer, which they're actually doing a lot of great work in terms of being able to visualize the difference in, you know, the shielded payments versus transparent payments, and like basically just showing us where we're at in terms of statistics for where we need to improve. And it's actually really interesting to see the block explorer, especially with the shielded payments, because you can see that there's no data there. It's like a transaction ID and then like a transaction fee, a public transaction fee, and that's it. So it's really cool to see that. I highly recommend it. It's called zchain explorer.zcha.in. And then we have a developer chat if anyone's interested in contacting us online, and also do weekly developer updates for our team internally. So all of these kind of near future priorities that we have in mind, we communicate how we're developing on them and how we're progressing and everything like that. So yeah, I think that covers everything I wanted to say. I think that's the last slide. Cool. That's it. Thanks.
Well, I have a question. So you mentioned that most payments today are not shielded. Do you, and you know, there's kind of an additional cost to making shielded payments, and also you can kind of free ride, I guess, by having others do the shielding. So do you view that as a danger, that it will be hard to get a significant portion of the payments to use shielded payments?
So the ratio has been increasing ever since launch. It's just been going in a positive direction. I think like probably a couple months ago it was closer to 25%. So it's slowly increasing. We might hit like a threshold or something like that. But I think with these infrastructural improvements, being able to offload that proving to a third party, whether it's like a trusted third party service or something that you set up at your home, I think that will significantly help. And similarly with the payment disclosure, like a lot of services we're running into or we're seeing are ones that are nervous about integrating the shielded side of things because their customers might attempt to say that they didn't get their money or something like that. So having that like concrete receipt to be able to prove that you made this payment I think is a really big step, and and we're also like working to make the shielded the zero knowledge proof generation operation to be a lot less resource intensive, but these are kind of like other ways that will help in the meantime.
One time I saw Zcash team is integrating Zcash solution into Ethereum platform, and in a business-wise, if you are able to use Zcash solution on Ethereum platform, would there be any reason for me to go through the Zcash is on network using Zcash?
Yes, we have like the team of scientists that developed the protocol, and we have a lot of there's basically just a lot of usability that we're able to do, I think, in terms of improvements to the original protocol and developments on, for example, the parameter generation and making zero knowledge proofs more efficient. So I think we have this like core team of scientists that are backing us and are able to help us improve the protocol. Perhaps. I mean, it's good that we have multiple implementations. Zcash has a couple of forks already, but I think it really comes down to being able to trust the developers and know that they're going to be, they have this team of engineers that have been working on this for a few years and know everything about it. I can't predict the future, but we are working with Ethereum on we're very friendly with Ethereum, and we're interested in helping them make Ethereum more private. So as long as things become more private, and yeah, we'll see how it goes.
Any more questions? All right, then. Oh, someone? No? Okay, then. Thanks so much. Yeah, we do the next talk in like 5 minutes. So if somebody wants to get a drink, please go ahead. So you guys are going to London next now? You're doing BOScoin. I think I saw it, yeah. Okay. stay like in this area.
Around here?
Yeah, that'd be good.
I'll try.
Okay, so this is Han for BOScoin. It's just for the live stream.
Oh, it's just for the live stream.
This room. It's
Oh,
actually
okay.
just for the YouTube.
Okay. All right. Hi, everyone. I'm Han from BOScoin, and we flew all the way from South Korea to meet you guys. So, thank you for having us here. We're really excited to be able to come outside of Korea and really talk about what we've been working on outside our own country. And hopefully you'll find some things that you'll find interesting, and maybe we can talk about some of those parts afterwards. Right, so let me just introduce you to our team, first of all. So our CEO is actually a fintech entrepreneur in South Korea, and he founded the largest financial information services in Korea, called Paxnet, and he's also one of the co-founders of Blockchain OS. Our CTO, who's also with us today, can you say hi? And he's basically the architect for the BOScoin platform. And so if you have any technical questions, you can ask him afterwards as well. And then there's me, the COO. You could just call me Han. And I used to work as a application developer in South Korea for banks. And recently I've come over to the Blockchain OS team and started working as a consensus developer. Also here with us today is actually Ash. Say hi, Ash. He's the one that's been asking all the difficult questions today. And he's been advising the BOScoin team for about a year now. And so he's incredibly knowledgeable about the blockchain space. So he's also someone you might want to talk to. So I'll go straight into the overview. So we're going to be talking about three basic things. So what exactly are we building? Who should be running it? And how will we grow it? Yeah? So what are we building exactly? We're actually building smart contracts, again, right? So as you all probably know, smart contracts are programs that enforce themselves. They run themselves, right? But we're doing it slightly differently. We're calling them trust contracts, and that's not the only thing that's different. Our trust contracts are programs that we can prove they can enforce themselves. So I guess you're going to start asking things like, why is that important, right? Why is it important that contracts can provably run themselves? Well, last year, I'm sure you've all heard about the $50 million DAO incident. Right? So the DAO is basically one of Ethereum's largest projects. Well, it wasn't until it broke. But the DAO basically stands for Decentralized Autonomous Organizations. And so what they wanted to do was they wanted to codify all the rules and decision-making processes onto smart contracts and have organizations run decentralized on the network. And so people love the idea. And they raised loads of money. They raised almost $150 million. It was the largest crowdfunding event up till then. But it was hacked, right? $50 million worth of Ether were withdrawn, right? And the reason that happened was because of a simple coding error, the recursive call error. And basically, that's kind of a problem that happens quite often in programming in general. Like software developers make mistakes, right? So we asked ourselves, how can we stop this kind of thing from happening again? Well, first of all, we kind of looked at what Ethereum is made up of. Ethereum is actually a Turing-complete language. It creates smart contracts on top of a Turing-complete virtual machine, which basically means that you can program anything you can think of onto the blockchain. So if you can program anything you want onto a blockchain, it basically means you can even program things that are logically impossible onto the blockchain. And so Ethereum's approach is basically to provide developers with as much freedom as possible. But we ask, at what cost, right? The approach that Ethereum uses with smart contracts basically means that after somebody writes a contract, you need to audit it and see if it's okay. And then you also have to look for bugs, things like recursive call errors, before the contracts are called or uploaded. So what we did is basically, we took a slightly different approach. We decided to create a Turing incomplete programming language. But instead of it being just incomplete, we made it decidable. So in computer science, decidable basically means that when you run the program always results in true or false. So it doesn't result in maybes, it doesn't result in I don't knows, or it doesn't get lost, basically. It always has to turn out to be true or false. And that's something that could only be done when you get rid of the Turing completeness. Right? So what happens when you start creating contracts that are decidable? It basically means that the contracts can never have unknown consequences. They're always right or wrong. And secondly, we can know beforehand how it'll run, right? So you don't actually have to pre-audit the contracts. We can actually pre-audit the contracts automatically before they're uploaded onto the blockchain. So by starting from a completely different architecture, we believe that this kind of structure can actually prevent accidents like the DAO from happening beforehand. Now, the second issue with the DAO. So after we know why the DAO happened, what were the legal implications? So an interesting perspective of the DAO was that the DAO wasn't a hack at all, right? I'm sure you've heard of things like code is law. The person that exploited the code, or the hacker, can claim that if you take away his codes, or if you take away his coins, it's actually an interference with his right to the coins that he created. All he did was use a code. However, at BOScoin, we don't really think that code is law, at least smart contracts anyway. Because looking at the legal definition of a contract, in English common law, it usually goes, a legal contract is a mutual agreement between two parties, right? And then there's the tiny bit that goes under that. It also means that each party must have the capacity to enter a contract. Now, when you run a smart contract, there's usually three parties, right? There's the developers, the participants, and the executor. And with smart contracts, and especially during the DAO, the developers didn't have the capacity to understand the contract, the participants didn't understand the contract, and maybe even the virtual machine didn't understand the contract. So what we wanted to do was we wanted to build trust contracts that were closer to actual law, right? And the way we wanted to do that is by improving the capacity to understand the contract that they're entering. So for developers, we chose a decidable language so we can decrease the room for error. We improve the readability of trust contracts so they can make decisions themselves. So our contracts are actually much more human readable than what smart contracts look like. And they're pre-auditable. So the VM can actually know, well, we don't have a VM, but on the blockchain, when you run the trust contracts, they can know how long they'll run beforehand. So I mean, when Bitcoin first came into the world, what they really did was they allowed people to move away from trusting banks, right? And Ethereum, when they came along, they gave us a whole bunch of freedom. But at the end of the day, when you look at smart contracts, what you're doing is you're putting your trust in the people that created these smart contracts, right? And what we want to do is we want to return that trust back to the people that actually do the signatures, right? The people that are participating in the actual smart contracts. So hopefully, our trust contracts, since they're specifically designed so that people as well as the programmers can read the code and interpret them the same way, hopefully this will improve the literacy of the contracts on blockchains as a whole. So to summarize, what trust contracts are they're provably executable contracts on the blockchain, readable by both humans and computers. So I said trust contracts are basically made up of two languages. It's made up of the web ontology language OWL and the timed autonomous language TAL. So this is a bit of sample code that we wrote up. And one of the largest differences is basically, if you look at smart contracts, the data as well as the logic, it's all written in one script, right? But what we did is we basically divided the data aspect of the contract and the logic aspect of the contract. And so the data is described using the OWL language, which is a semantic language. And then the logic is divided into another script called TAL script. What this division basically does is it improves readability, and it's also a very common programming pattern, I guess, because it's, I guess a lot of people just call it data-driven development. And we structured our trust contracts so that we can clearly see where the data is and where the logic is. Now, I'm sure some people might know what web ontologies are. Sorry. But this is basically what a web ontology language looks like, right? So this is how we describe data on trust contracts. And this particular data is actually a set of data about crowdfunding. So you'll see things like funders and funding and interest rates and everything that's involved with crowdfunding. But the reason we use OWL to describe data is because of the structure of how, it's because of how they structure their data. Basically, the structure of ontological languages is usually done in triples. So they use things like objects, attributes, and relations. And using those three sets is basically how they can describe any kind of knowledge that we've picked up over the years. And not only is it described in this way, basically our ontologies are actually shared. So once somebody creates intelligent data, is what they also call it, anybody can use this kind of data set in their trust contracts as well. So the more and more trust contracts you create, you're actually adding to the reservoir of knowledge that's on top of the blockchain. Right. Now the second part is the timed automata language. This is actually a language that we created within our company. Timed automata is actually quite an old theory, but applying it to blockchain technologies is actually quite new. And one of the first features that it does is it does operations, right? So I said in the sample code above, there's OWL that describes the data, and TAL that describes the logic. And so one of the first features that it does is it does operations. So like adding and subtracting the data. So that's how we mold the data into the output we want. Secondly, what it does is it limits operations through time, right? So if we look at, I'm going to compare this to Ethereum in a bit. So what you can do is you can model operations through tools like the ones on the left as well by using these, using time as a limitation. And because we're using a decidable language, we can pre-calculate how long every combination of logic within a trust contract would take. So why is time important? When you give people the ability to create programs on the blockchain, not only do you give them the ability to express anything they want, you also provide them with the power of process spamming your network. So this is something that happened quite often. Like in a lot of times, Ethereum is actually spammed by these kinds of transactions. And basically what they do is they create really complex or infinitely looping contracts with the intention of overwhelming the network. So what Ethereum did was they constrained this kind of activity by having the contract consume a limited resource for each operation. And that limited resource is basically gas, right? And gas comes from Ether, the currency. So what Ethereum is doing is they're using an economic model to limit DDoS attacks on the network. But what if the value of the attack is greater than gas? The economically rational being would attack the network until marginal gains from the attack is equal to the marginal cost of the attack. And so they'll just keep on attacking and attacking and attacking until until they stop them, right? And that's what happened with the DAO attack as well. The marginal cost it took to run the malicious code was actually way, way lower than how much coins they could create through the hack. Now, what BOScoin does is it just uses time. So all we do is we see how long the contracts will run beforehand, and if it takes too long, we'll stop it. That's how simple it is. So, I mean, economic models are really important. I mean, that's why Bitcoin took off in the beginning as well, right? But applying a secondary economic incentive model to the processing power only complicates things. Because gas is also used for transaction fees, miners want to make, miners will try to only put smart contracts that have high gas rates, and users will only want cheap contracts. So there's a bit of a conflict of interest in that aspect as well. So, so that's basically why BOScoin uses a timed automata model rather than an economic incentive model. So I kept on talking about TAL and OWL a lot, and not a lot about BOScoin. And so this picture is basically how it fits together. The TAL and the OWL language actually sits on top of OWL chain, the protocol layer. And that's completely separate to the coin layer, which is also referred to as the platform layer. So everything regarding the issuance of the coin, as well as remittances, and we also have a governance feature, that kind of thing, they all lie on top of the platform layer. And all those functions are actually written in OWL and TAL. So they're written in the trust contract language. So on to the next part. Who should be running these decentralized systems? So I'm sure everybody knows about the Bitcoin blockchain debate, and I'm sure everybody's heard too much about it, right? But again, we thought there should be a way to solve this, right? And we thought the reason these problems just don't go away is because of these 4 things, right? Bitcoin doesn't know who should be making the decisions. Should it be the exchange providers? Should it be the people that have the most Bitcoins? Or should it be the developers? Nobody really decided who should be the ones that should make the decisions. Additionally, nobody knows where they should make the decisions. There's no like single place that people should go to make decisions. And then there are the rules. Should it be more than 50%? Should it be more than 70%? And then lastly, even though they develop something, like such as SegWit, there's no real way to force people to get onto the new updates. So what we decided to do is to make some decisions. We said, the people that make the decisions are going to be the stakeholders. So for BOScoin, the people that are the stakeholders are the node operators. They have to put some stake into a node for them to be a stakeholder, and they get 1 vote for that. Secondly, where do you make decisions? We actually embedded the governance system into the BOScoin platform. So you can vote within the system. Thirdly, what are the rules? The rules are actually all defined within the trust contract. So whether there should be a majority vote or a 60% vote, or how long the vote should take, like all this information is actually defined within trust contracts. And thirdly, how do we implement change? We have automated updates. So automatically, after you decide on a rule, these updates can be implemented. So this is how a basic proposal works. We actually have 2 different types of proposals, one that asks for money and one that wants to change the system. And so for a basic proposal, it's actually quite similar to Dash. What you do is you write a proposal, and then you upload it onto the blockchain, and then the node operators have a vote. And if that proposal is passed, the amount that they asked is sent to the person that put up the proposal. So it's pretty simple. The system proposal is a bit more interesting. So as I said, all the rules within BOScoin are written in trust contracts. And so all the rules that are written in trust contracts can also be updated according to proposals. So for instance, if you wanted to raise the transaction fees for BOScoin from 0.1 BOS to 0.2 BOS, what you could do is you could update the code yourself. You could say, you could update the the trust contract that used to say BOS transactions are 0.1 BOS, and you could update that to say now they're 0.2 BOSes. And obviously that won't be implemented automatically. It would have to go through a vote. So after you upload the proposal onto the governance network, people will vote once again, like before. But this time, when it's passed, we assume that the network has a consensus on the updated information. So what happens is that the trust contract itself that everybody is referring to is updated, and everybody on the network updates all together. So this is a feature that automates the updated features within a decentralized network. Right. And lastly, so how will we grow? You know, there's a lot of currencies that come out every single year, and it's the same for Bitcoin almost. I mean, I know all of you here are really enthusiastic about it, but growth is still something really hard to kickstart. And I guess one of the reasons is because it's always like, should the chicken or the egg come first? I mean, if you're on a currency, you need both sellers and buyers. And sellers won't come until there's buyers, and buyers won't come until there's sellers. So what we decided to do is we're going to kickstart our own platform. We've actually developed a couple of applications, and this one is just one of them. It's actually a prediction market for celebrities, and we're actually using some of the commons budget that we have issued from within the issuance schedule to develop these kinds of consumer-facing applications to get people onboarded. Right. So we've been developing this product for over a year now, and we're almost up to the testnet date. That's at the end of this month, and then in the middle of April we'll be having our first ICO. Which you guys can all participate in if you want to. And then we have our Genesis block launch, which is on the 30th of June. And then we'll be launching our iPhone and Android wallet specifications in our Nebula block. So hopefully things will go to plan. And that's basically a wrap for BOScoin. Thank you very much.
Just one question quickly. So you mentioned that instead of gas, you use time, but then, I mean, presumably different types of transactions would take different amounts of time. Does that mean they cost different amounts, or I didn't quite understand what that actually means when you say time.
Right. So at the moment, we don't have different prices for I guess very complex trust contracts and like simple trust contracts. At the moment, all transaction costs are fixed at 0.1 BOS, and all we're assuring to the network is that all contracts will either succeed or fail within a set amount of time. That's all we're promising to the network.
Is ideal user and ideal use case for you?
So who's the ideal user for you?
I guess so we're a public blockchain. So anybody can really create nodes and participate in the governance system. So what we really want is to get average users to get really involved in this kind of technology as well. And that's why we have things like consumer-facing applications as well, and like things like smart contracts as well. They're not going to be written in a programming language. They're going to actually look very similar to legal contracts as well. And so hopefully people that can basically read will also be able to participate in creating trust contracts.
Do we have examples?
I don't think you'll be able to see the code because it's actually quite small. We don't have any large ones at the moment. So no, not today. Sorry.
So you said there's going to be a pool of trust contracts that are going to be developed as the platform progresses. Yeah. And then when I develop a trust contract, it's going to be added to the pool. And at the end, you're going to have a set of awesome pools that people can, trust contracts that people can choose from?
Yeah, that's.
Okay. And you build using these trust contracts, you can build dApps, as Ethereum calls it, or?
Yeah, decentralized apps are on the milestone. And yeah, decentralized apps are obviously on the milestone, but the applications we're creating right now are actually separate from the blockchain. But in the future, yeah, definitely, like decentralized applications is definitely somewhere we want to go.
Lots of questions.
So, cool presentation, thank you. In the logic side, you still have a state machine that has its own state, sequential circuit, and so limiting by time is interesting. But at the end of the day, I'm wondering what sort of guarantees are you able to provide, and how does this compare to work in Ethereum, for example, with formal verification? At the end of the day, you're still dealing with a state machine, and you've got many challenges there. So I'm just looking for the differentiation.
질문을 내가 정확히 모르겠는데 지금 그 타임드 오토마타에 대한 설명을 원하는 것 같은데 맞나? 질문?
So, could you clarify your question just a little bit? As in, what's the difference between Ethereum and using Tau?
So at the core, you've got, it's not a combinational logic circuit, it's sequential, so it has state, right? And you're proposing, the problem is the halting problem, right? So when does this thing stop? Ethereum stops it with simply saying you've run out of gas, right? You're saying let's stop it based on its run out of time. That's the core. But you can do a lot in a second, right? 1 megahertz, you've done 1 million operations, right? So I guess I'm confused as to is that the essence of the difference? Is it simply time versus gas? And does this get to the heart of addressing the halting problem, maybe? And related to this too, so that's part one. Maybe you follow? Yes? Okay. So, and part two is, one thing that you can sort of get at is simply how in circuit land they got at it with formal verification, right, for smaller circuits. This is the path Ethereum is going down, where you're saying, okay, I can cover all these states in this space over this period of time, and you can actually formally prove it. And so that's how Ethereum is going down this path to solve it. And I'm wondering if, as Ethereum rolls out formal verification, it might reduce the delta. So what is the answer to that? And I like the path. I'm just curious.
Okay.
It's a nerdy question. I'm sorry.
지금까지 질문이 뭐였는데?
그러니까 뭐 시간이라는 개념으로 너무 막 쉽게 해결했다는.
아니 그게 아니고 타임드 오토마타는 그 인피니티 오토마타를 그 피니티 오토마타로 전환하는 기술이에요. 그러니까 지금 보면 핵심 기술이 뭐냐면 버추얼 머신이 이제 그 지금 튜링 컴플릿 머신을 시간 제한을 줘서
environment. And so obviously Ethereum has to go down the path of reducing errors that can be caused due to Turing completeness. But we're just starting with a slightly smaller scope. And hopefully, I guess at the end of the day, it really depends on who has fewer hacks. And I think only time will tell from that perspective. Yeah.
Okay, well, let's.
I will just like to add an opinion on it. I've been running Ethereum community in Korea for 2 years, and like there's been so many things problematic around Ethereum, and is to take like many discussions. I will happily do that. And for Ethereum, like you mentioned, there's a gas to stop like infinite looping. Like there's a language like looping language for while code, and yeah, like it boosts the efficiency. But the Ethereum way to stop abusing it is just put the gas process, right? So once you run out the gas, it stops. The problem is the attacker is able to keep processing the gas. You just need to pay. So just recently, as recently happened in Ethereum memory pools and their transactions, you just need to pay because it's cheap. Why it's cheap? Because to platform to go process and platform goes boost its ecosystem, it must be cheap. Fee must be cheap, right? So many platforms and many applications on top work on itself, and many people can join. If the fee is too expensive, like ecosystem wouldn't work, right? So that's why they put cheap gas price and fee price. But it's kind of contradictory, I think, because to stop the attacker, it should be expensive. It's too cheap for attackers. So why don't you separate the two contradictory factors? So why don't you put just time on attacker side and maintain the cheap price on the platform side? So if you put a time and if you can predict how long the code takes, then the miners can choose, the validators can choose if they want to run this time of the code or not. So they get to choose and still maintain the low fee price. That's how it works, I think.
Cool, very interesting. Okay, well, thanks so much, guys. Okay, so we have one last thing. So probably many of you are familiar with Augur. Tom here, who works for Augur, he's in town, and he just wanted to give a brief update about what's going on with Augur. So. Do you?
I don't necessarily need it. I can just talk. I mean, I was just.
You don't need slides.
No, I mean I don't have slides. I'm just gonna show.
Okay.
The one
You can show the. Do you want to show this?
Yeah, if I can plug it in. I don't know if you have an adapter or something.
Do you have like the AirPlay thing? Where's the AirPlay?
AirPlay display. No.
Is it off? Huh. Does somebody know? Oh, event space too.
Yeah. 4061.
Cool.
Cool.
Hello. My name is Tom. I work with Augur Project, and we are a decentralized prediction market built on Ethereum. I'm going to try to give you just a very quick rundown of what Augur is and kind of where our state is right now. So essentially, Augur has two main parts. It's a decentralized trading system and a decentralized oracle system. You add those two together, and we can have a decentralized prediction market. So about 2.5 years ago, 2 years ago, give or take, Augur did a crowd sale where they sold reputation tokens, and the reputation tokens are used by people who want to participate within Augur and help resolve events. One of the key parts of a decentralized prediction market is that there's no centralized source resolving these markets for you and telling you how the events actually ended. So people who own rep can come into Augur once every 2 months, and we give you a random assignment of markets to report on. We take the mean, or we take the average of everyone's reports and use that to resolve the market. That way, we're not here, telling you what happened with these markets, and there's no centralized point of failure with that. Essentially, this is Augur. We recently just launched a new trading page here, but it's separate. It's in different categories here. You would go on. Anybody can come on and create a market for pretty much any event. We start with our 3 main biggest ones would be a yes or no market, a multiple choice market, or a range of different values. Anyone can come on and do this. Anybody can come on and bet on any sort of markets as well. We use Ethereum as our settlement currency. We're planning on supporting essentially all ERC20 Ethereum token types as payment within the app, in coming times. But so I'll give you a quick rundown for an example of how would you create a market on Augur here. So let's do a yes or no market with will it rain more than 1 inch in San Francisco on March 18, 2017. Then you would pick your resolution source. So essentially this is telling the reporters when they go to resolve your markets where they can look to find this data. They really can get the data from anywhere, but we can point them to a place to look for it. So this would be detailed on a publicly available website, Weather Underground. You'd select your end date, which would be March 18th. Go to additional details. That's pretty straightforward. Event topic, weather. You can add some keywords, raining, San Francisco. You can set your maker and taker fees. So the idea with Augur is that we don't filter. It's decentralized, so we don't filter what markets can be put on Augur. Anybody can put anything. So there can be multiple markets for the same event. Essentially it's going to be. Essentially, it's going to be who has the most liquidity and who has the best fees. So there can be multiple markets for the same event. So you can set those fees. You set some initial liquidity in here. So you fund your account with Ether. I can set some initial liquidity for whatever I want. So we can add orders in. Oh. And then we would do, oh my God, that's my old business partner. Create market. And now there will be a market on Augur for, will there be more than 1 inch of rain in San Francisco tomorrow? Anybody can go in. That's a binary market, so anyone can go in and buy shares, yes or no, on what that will be. If you buy a share for yes at 40 cents and it ends up, actually raining more than 1 inch in San Francisco tomorrow, you'll be paid out, a full $1. Your set will complete and you will make, the difference on what you purchased your share for. But essentially that's Augur. If you have any interest, we're relatively open and public with everything. Everything is on GitHub. We have a relatively large Slack group with about 2,000 people. You're welcome to join and come ask us questions. Right now, this right now is running live. This is on my private one, but we're up on app.augur.net. It's running on the Ethereum testnet currently. We've just shipped a couple of our key management libraries for the front end off to security audits. We're looking to get the contracts audited in probably the next 2 or 3 weeks, at least starting to enter that. And after that, we're going to do a bug bounty market. Essentially, will this market be hacked on the live mainnet? Let that run for a month or 2, and Augur should be live by presumably the end of summer this year. So if you have any questions, feel free to reach out to me. Feel free to join our Slack or whatnot.
Thanks. Can you elaborate a little bit on costs? Like, unfortunately, Ethereum gets really expensive now. What do you pay?
So I can actually, let's see if I have, this will show the cost cost of a transaction that we just did. So yeah, there's definitely a cost involved. The user will pay the cost for executing the transaction. So for example here, this was something I did earlier, it was a test, it was a test share. Total cost here was 0.8 ETH. So this is running on the testnet, and this isn't necessarily accurate, but yes, there are fees associated with placing your bet on the market, and the user will have to pay that. That's kind of the cost of us being able to do this in a truly decentralized manner built on Ethereum.
Okay, yeah, I can first start just to inform. I just checked. Ethereum reached a new all-time high, 40 euros, for just 2 minutes ago. So, but you mentioned this, and it comes with like natural thing of decentralized market. So maybe you're aware of this assassin markets concept, and are you then thinking of if someone puts up a market that is, let's say, the government or so is not seeing favorable upon? How have you heard anything about this from your to your company and so on, or do you have any thoughts on this? Like, yeah.
So if you're talking in terms of like quote unquote what a government would deem like an illegal market or an illegal action or something deemed non-ethical, when reporters go to report, actually there's an option for reporting a market as unethical. So if you do a market of will so and so be alive by the end of the month, when that would go to resolution, presumably majority of the reporters would mark that as unethical, because if they didn't, if you resolve the market incorrectly, or you give the non-majority answer that wins, you will lose a portion of your reputation. And it's essentially you got to put your money where your mouth is. So we have an unethical option, and that will hopefully weed out most of that type of stuff. And to be honest, the quote-unquote assassination market question, if anyone really wanted to do that, there's probably more efficient ways to do that with like crowdfunding contracts and whatnot than using a prediction market.
So I have a question too. I mean, the security model seems a little bit problematic here. So let's say I'm putting up, I own some weather site or whatever, and I put up this market, and I put up my own site as the the source you go to, and then all those people to verify the event, presumably 95% are just going to be very lazy. They're going to click that and they write exactly that, right? So I mean, how do you deal with that threat?
So essentially, the thought is that, say in that concept, 95% of people used the incorrect source and reported that it didn't rain in San Francisco when it actually did. Essentially, anybody on Augur can bond and fork a market. So after a market resolves, if there's one person out there that sees that market that says, hey, it didn't rain in San Francisco when I know it really did, and I go and I double check and it really did rain and I don't know what happened here, you can essentially bond and fork that market and say this resolution is inaccurate, and you have to put up some money to do that, and if you are incorrect, you will lose your money for doing that. But that essentially sends it back into a resolution period, and it'll go back to a new set of reporters, because markets are assigned randomly to reporters. So it'll go back to a new set of reporters through another resolution period, where essentially the same stuff will happen again, and then if it actually resolves incorrectly again, that same person can bond it again and actually fork reputation. You can fork the reputation token, and there would be two different types of reputation, for that one market, and then presumably over time, whichever one continued to have usage and have the more liquidity would win out. But we call these backstops. So we have these two backstops in place for if the markets end up resolving incorrectly, people can put some money up and attempt to fix that and resolve it.
So if I understand correctly, the reporters are the ones that own the rep tokens, and what's in for them? Like, because it seems like it's work to actually do that. So how do they gain?
So with this, like Augur doesn't make any money off this. We just, the Forecast Foundation, what is, Augur project, just maintains and supports this protocol. We don't make any money off of this. So there's market fees. There's essentially a 2% market fee. 1% of that will go to the person who creates the market itself, and the other 1% of it will go to the reporters. Not specific to the market that they report on, the total fees of the collective platform within that reporting period. So essentially, if you report correctly, you will make money.
So I got a question regarding two ways of attacking the system and how you would deal with it. First one is simple, like spam. If I'd create 1,000 markets, then these 1,000 markets would have to be resolved. And if I create 1,000,000 markets, maybe there are not enough people to resolve all these markets. And how do you decide which markets to resolve and which not to resolve? And the other one is similar. How do you deal with things that are impossible to resolve? So if I ask, was my dog happy yesterday? Will he be tomorrow? And then no one knows the answer to that. How do you deal with these two types of problems?
So essentially, there's a cost to creating a market. Creating a market isn't free, so there's a bond. You have to put a bond up. It's calculated based off of a couple different variables, such as like the time of the market, how much initial liquidity you're putting into it. Are there other markets that are in the same like tag and category group? Right now, it's looking, when we were doing it on testnet here, it was calculating out to about $10, $11. So there is a bond for creating a market. So I mean, if you have a lot of money and you want to spam, I guess you can do it. But in theory, you can't just make up 1,000,000 free markets. And second question with reporting, along with the unethical. So essentially you have three options when you report: either answer the question, report it as unethical, or report it as you can't determine it. And that, presumably would take care of the question of, was my dog happy yesterday?
It's about scalability issue regarding reporters. And for example, myself, I have some tokens, and I wouldn't like to bother to photo report because I'm just speculating. I wouldn't want to work because I don't have time as well. Like in a second, the market gets really big, and like in a second, like there's hundreds of prediction products, and how reporters work, how reporters ever get their result sent to the market because they don't have time, they have a real world job. I think there's kind of a scalability issue there.
So that's not necessarily a problem that we're directly attacking here. Our take is that if we incentivize reporters correctly and that they're going to make money for reporting on these markets, they will come and do that. Say only one guy resolves a market or 10 guys resolves a market. That's more for them. Obviously, that's not good for decentralization. We have many thousands of people who own the reputation token, but in theory, with that, we would presume that over time, when this actually launches, there's probably going to be people who make like augurreporting.com, which like aggregates all of our markets and like puts the answers there for them and like makes it kind of easy for people to get these answers. Again, while that's, necessarily, people aren't all sourcing the answer themselves, if you do that to the large enough scale and you have enough reporters, we should still get, a fairly accurate result. And even if not, you can fork and bond the markets and whatnot. But presumably there's going to be a lot of services and kind of like helper tools built on top of this by, members in our community that are already starting to do this type of stuff. So that is one thing. Someone's actually planning on making like augurreporting.com that will aggregate our markets and give the answers for people very simply. You go to there and it shows the market you need to report on and what the answer was. If you want to trust that as your Oracle system, more power to you. Well, if everybody used that, that's a potential case. But again, in theory, I actually don't have any numbers or statistics. We can't really tell how many people own rep, to the beauty of this. So we don't know how many people will be reporting and using on this. But presumably speaking, we can assume that not everyone is going to use augurreporting.com. And even if everyone does and Augur Reporting gives the wrong answer and everyone resolves the market incorrectly, there's going to be one guy who wants to come in and take the market fees for that market and will bond it as incorrect. And it will resolve correctly eventually.
All right, we can do like 2 more questions if somebody else has any. All right, well then, thanks so much. Yeah, thanks so much everybody for coming. So there's still beer, so feel free to hang around a bit. If you want to leave, just go through here and to the left to go back to the elevator. I think actually you can get out in any elevator, I think, but yeah. You don't need a card to get out. So thanks so much for coming.